guys, and welcome to Azul Coding. In this video I'll show you 3 different ways you can check the user's network download speed in WPF. As always, there will be a link to all the code in the description down below. I'll be writing this in C#, but there's a VB.NET translation available if you follow that link. I've already created some text blocks in this very simple user interface, and we'll replace those 3 dots with the network speed when we have it. So let's get started and look at the first method. We'll first use a NuGet plugin to test the network speed. To install the plugin, go to Tools, NuGet Package Manager, and then Manage NuGet Packages for solution. In the Browse tab, search for Speed Test, and then install the speedtest.net core package. Essentially, this plugin uses APIs from such providers as fast.com to calculate the download speed. Next, we'll add in the necessary import in the code. I've gone ahead and created the function we'll be using for this method. Notice this async keywords here. We need that because the plugin uses an asynchronous function that essentially runs behind the scenes so as not to freeze the application when it's running. Now I'll calculate the speed using the getDownloadSpeed function, passing in the units parameter for megabits per second. Because this function runs asynchronously, as I mentioned previously, we need to make sure it completes before we update the UI. We use the await keywords here to do this. And then we can update the text block control with the speed rounded to 2 decimal places like so. Let's call this function when the app starts and test it to see how it works. This method takes quite a while to analyze the network speed, and we can't see a result straight away as we might do on the fast.com website itself. Once the speed is generated though, we get a fairly accurate result. You can customize this plugin to use speedtest.net instead, and modify the config settings to your liking. Let's try a quicker method by using network interfaces. I created a different function this time, and set it to run on load as before. We start by getting all network interfaces, devices, adapters, etc. Then we loop through them. Given that this includes all network devices such as Bluetooth, Ethernet, Wi-Fi, etc., I'm only interested in my wireless adapter which has 802.11ac in the description. Yours might be different, and so it might be worth putting a breakpoint here and hovering over the adapter variable to check the details. If you're creating an app for multiple users, it might be difficult to identify the correct adapter, but if you're coding for yourself, this might not be a bad choice. We'll now update the text block control as before, making sure to convert the value to megabits per second and break out of the for loop. Now we have our result. Let's test it and see how it works. That's a lot faster this time, but this figure doesn't seem to update in real time and could only be a static average for your network adapter. This might be useful in some situations, but it might not be ideal for real-time analysis like our first example. Let's try our final method, which uses web client. As before, I created a new function and set it to run on load. In this method, we'll download a file 5 times and get the average time it took to download, converting that to megabits per second. We'll start by setting up the for loop like so. For this example, we'll download a jQuery file, but you can use any file you want. Just make sure you know the size of the file and put that size in this variable. We'll set up our web client and get the time before the download takes place. Then I'll copy in the code to download the jQuery file, put it in my downloads directory for now. Notice this @ sign before the string lets me write it without having to escape the backward slashes. We'll finish by getting the time after the download and doing a quick calculation to convert the time to kilobytes per second. Now let's update the text block control by taking the average speed, making sure to convert it to megabits per second by multiplying it by 0.008. Let's test it and see how it works. Now that result seems a bit different to the others, and that's probably because the jQuery file is quite small to generate an accurate result. So the larger the file, essentially the more accurate the result would be. But bear in mind it might take longer to get a result. But notice in the downloads folder, the jQuery file is still there. Let's delete it by adding in a line of code. Now it's generated the speed again, and the jQuery file is no longer in the downloads folder. So that was 3 ways to make a network speed test. I'll leave it up to you to choose your preferred method. If you're looking for an example app to learn WPF in more detail, I created a suite of WPF desktop apps that are all open source. check out the link in the description to find out more. All of the Codeness videos available on my website, and be sure to head to the channel for more WPF tutorials. Don't forget to leave a like if you enjoyed this video, and subscribe for more content still to come. Why not check out these other videos on the channel as well. Thanks for watching, and I'll see you soon.